You know, the world of AI is moving at, well, lightning speed. It can feel almost impossible to keep up. But don't worry, that's what we're here for. By the end of this, you're going to have a really clear map of the whole landscape, who the key players are, and what groundbreaking tech is literally changing everything. So let's dive in.
So for a while there, it kind of seemed like AI development was on this pretty predictable path, right? You had a few big labs dominating everything, but then one single unexpected event happened that just completely flipped the script. It kicked off this global competition, this frenzy that we're all seeing today.
And that brings us right to the first big theme, the great AI race. We're talking about a super high-stakes tech race between nations. And believe me, this isn't just about who can cook up the smartest algorithm. No, this is a battle for economic influence, for control over critical resources, and really, for the power to shape the future of technology itself.
So, what was this big moment? It was what people are calling the DeepSeek moment. Basically, this Chinese company, DeepSeek, came out of nowhere and released a model that was nearly as good as the very best in the business. And here's the kicker. They claimed they did it way cheaper and much more efficiently. It was like a shot heard round the world. Suddenly, everyone realized the top spot was totally up for grabs.
And this really shows two completely different game plans, right? On one side, you have Team USA. They're mostly focused on building these closed, proprietary models. Think OpenAI's ChatGPT or Anthropic's Claude. The goal? Sell AI software and services. But Team China is playing a totally different game. They're dropping these super powerful open-weight models for anyone to use. Their goal isn't just to sell something, it's to build massive international influence by becoming the foundation for everyone else's tech.
And here's the thing you really got to understand. The top researchers, they're constantly moving between labs, so there aren't many truly secret ideas or algorithms. The real battle, the real bottleneck, it all comes down to budget and hardware. It's about who can afford the insane cost of the compute power. We're talking about those powerful graphics cards, GPUs, that you need to train these absolutely gigantic models.
Okay, so this whole competition brings us right to the heart of the matter. It's the central debate in AI today, this big philosophical and strategic clash between what we call open and closed models. So, what's the difference? Let's use an analogy. A closed model? That's like the secret recipe for Coke or your favorite restaurant's special sauce. You can enjoy the final product, but the kitchen is totally locked down. You have no idea how it's made. An open-weight model, on the other hand, is like getting the whole recipe published in a cookbook. You get all the ingredients, all the instructions. In AI, these ingredients are the model's weights, basically the millions of numbers that hold all its knowledge. And the best part? Anyone can take that recipe, tweak it, and cook with it in their own kitchen.
Which of course brings up a huge question, right? You might be sitting there thinking, wait a minute, why would a company spend millions and millions of dollars developing this amazing tech just to give it away for free? It sounds kind of crazy, but trust me, there's a very, very clever strategy at play here.
Okay, let's break down the genius of this strategy. First, influence. A lot of companies in the US, for example, are never going to send their private data to a Chinese-hosted AI. Security concerns, right? But what if you give them the model itself? Well, now they can run it on their own servers. All their data stays private, total control. Plus, they can customize it for whatever they need. Law, medicine, you name it. And these models often come with super flexible licenses, no strings attached. It's a brilliant way to bypass security walls and become the foundational technology that everyone else starts building on top of. That's real power. So, you might be wondering how these new models can be so powerful and yet surprisingly efficient. Well, a lot of the secret sauce is in the architecture. It's time to talk about the magic behind something called a mixture of experts, or MOE. Okay, think of it like this. An old-school AI model is like one giant brain trying to do everything at once. It's a jack of all trades. A mixture of experts model is totally different. It's like a team of specialists. You've got an expert for history, an expert for poetry, an expert for coding, and so on. And when your question comes in, a smart router looks at it and says, aha, for this, I only need to wake up the history and poetry experts. It only activates the relevant specialists.
So let's walk through it step by step. Step 1, your query enters the system. Step 2, the router intelligently picks just a small handful of experts that are right for the job. Step 3, only those selected experts fire up and get to work. The rest of the model stays off, saving energy. And finally, step 4, the answers from those few experts are combined to give you one super informed final answer. Simple as that.
And the result? It's a game changer. The computational cost for a single query just plummets. You can see it right here. That means labs can make their models way, way smarter. They can just pack in more and more experts, but the cost to actually run the model doesn't skyrocket. You get the best of both worlds, a bigger brain that's also way more efficient to use. It's how you get smarter, not just harder.
Okay, so that's all the high-level, kind of nerdy tech stuff. But how does this actually affect real people, building real things? Well, let's zoom in on one of the most exciting areas where this is all coming to life: AI-powered coding. So how are developers actually using these incredibly powerful new models? Well, their ability to understand and write code has kicked off a whole new generation of tools. But what's really interesting is that we're seeing two very different philosophies emerge about how to work with an AI coding partner.
Okay, so on one side, you have tools like Cursor. You could think of this as the micromanager approach. It feels like a traditional pair programmer sitting next to you. It suggests code changes, and you review them line by line, approving or rejecting each one. But then you have something like Claude Code, which is more like the architect. Here, you're not in the weeds. You guide the entire project from a high level, just using plain English. You trust the AI to handle the nitty-gritty details. It's this whole new way of thinking. It's basically programming with English.
Now, I know all this tech can seem really intimidating, maybe even a little overwhelming, but the truth is, it's more accessible than it has ever been. So for this last part, let's talk about how you can get involved. It's your turn. Let's talk about how to learn by building.
Honestly, if there's one piece of advice I can give anyone who wants to truly understand this stuff, it's this. The best way to learn something is to build it yourself, from scratch. I mean, reading about it is great, but getting your hands dirty and actually building a model, that's where the deep, real learning happens, no question.
So, where do you even start? Here's the roadmap. First, start simple. Don't try to build the biggest, baddest model out there. Begin with a classic, something you can actually wrap your head around, like GPT-2. Then you start to tweak it and evolve it. You can add new components, change things around, and slowly turn it into a more modern architecture. And the whole time, you can actually verify your work. You can compare your model's output to the official versions to make sure you're on the right track. It's a real step-by-step path to understanding this from the inside out.
So there you have it. The landscape is changing, and it's changing fast. We've got this intense global race, this huge debate between open and closed models, and these amazingly efficient new architectures making it all possible. And the most important part, the tools are here. They aren't just for massive tech labs anymore. They're for you. So the only question left is, what will you build first?